What's up, Panthers? All right, so we got another tutorial video here. This one's on trigonometry. So again, things that you all should have gone over before that we did go over in class actually. And I'm just doing a brief tutorial to kind of catch you all up to speed on anything you might have forgotten so that you can complete the packet work. All right, so we got a simple short video today. We're going to be covering two topics basically. So what are sine, cosine, and tangent, and then how do you use them when working with triangles to identify sine, cosine, and tangent. All right. So when I'm talking about sine, cosine, and tangent, I'm referring to these things. So sine of theta, cosine of theta, and tangent of theta. Okay. Now, sine of theta, cosine of theta, and tangent are theta of theta. These are all functions. So sine is a function. You plug something into that function to get out a number. Cosine is a function. Tangent is a function. Theta is an angle. Okay, so when we are working with them, we'll be looking at the different angles and triangles. And that angle is what we would plug into our function sine to get out an answer. Okay. Normally that's how it works. We're going to be using it slightly differently. All right. And I'll explain that later. So sine of theta is the opposite over the hypotenuse. Cosine of theta is the adjacent over the hypotenuse. And tangent of theta is the opposite over the adjacent side. Okay. So sine of theta, cosine of theta, tangent of theta. What we're going to be doing is we're going to be setting up these fractions in our problem. So it might be easy to say, oh, I know what the angle is, so I'm just going to type in tangent of the angle, and that'll give me an answer, but that's not what I'm asking you to do. I'm asking you to look at the triangles that you just solved for to find all the sides, and you're going to pick out what's the opposite side, what's the hypotenuse, and you're going to write that in a fraction, opposite over hypotenuse. You're going to identify what's the adjacent side, right? What's the hypotenuse? And you're going to write the adjacent number over the hypotenuse number that you found, those measurements, okay? So this is kind of just written out in another way for you all to recognize what I'm talking about. But everybody's heard of SohCahToa by this point, right? I like writing it like this. But I know some students like writing it like this, SohCahToa, all right? And all that's saying is sine of the angle theta is going to be your opposite over hypotenuse. Cosine of your angle theta is adjacent over hypotenuse. Tangent of your angle theta is opposite over adjacent, okay? So these are both saying the same thing, just two different ways of writing it, all right? So now let's jump into how do we use these in a problem, okay? So when we're given a triangle, let me draw one. Again, we're only working with right triangles. A right triangle means that between two of the sides, there is a right angle, okay? They're perpendicular to each other, which makes this right angle. And that's what we'll be working with in this problem, okay? So let me label this 5 inches, 4 inches, and 3 inches, okay? So now, let me label this 42 degrees and 38 degrees, okay? So in these problems that we're doing in the packet, I'm asking you all to, first of all, label your sides, okay? And then after you label your sides, you're going to go ahead and write the fractions, okay? But that's not all I'm asking you to do. So you see how there are two angles in this problem? I'm asking you to do sine of theta, cosine of theta, and tangent of theta for each angle, okay? So what we can do right now is we're going to try to make this a little simpler for ourselves because we're going to write sine of 42 degrees, cosine of 42 degrees, tangent of 42 degrees, all right? And then we're going to come over here and we're going to write sine of 38 degrees, cosine of 38 degrees, and tangent of 38 degrees.